Well, hey there, Huskies. Doesn't this take you back to 7th grade? Whoop whoop, video lessons. All right, hey, so on your desk, just to get started, you need your activity sheet from yesterday so that you can use that as a reference tool today if you need it as you move forward with today's notes. But first, I do want you to go ahead and work in your math spiral on your bell work. So notice today we're rewriting the following numbers in scientific notation. This is based off of the bell work we did yesterday. So now instead of identifying them, you are actually in charge of writing them in the correct form. And then just see what makes sense. Remember your idea of dividing by 10 and multiplying by 10. What does that do with the decimal so that you know how to write your correct exponents? So before we get too deep into our lesson today, go ahead and pause the video and give yourself a few minutes to rewrite A, B, C, and D in correct scientific notation. Remember, it needs to be between 1 and 10 as your first official number, and you need to be multiplying that by a power of 10. All right, so in your math spiral, you should have the following. A should be turned into 5.263 times 10 to the 10th. As I multiply by powers of 10, that decimal moves to the right if my exponent is positive. And if my exponent is negative, that means I'm moving that decimal to the left in order to simplify. So you kind of do the opposite as writing it in scientific notation. Please write these down, the original numbers and your scientific notation in your math spiral so that you have something to look back on to refresh your memory when we need it. Excellent job. All right, for our learning targets today, you can see that we are going to discover the surface area formula for cones. And we're going to be doing that using that information that we looked at yesterday as well. So go ahead and make sure you have a notes sheet before you proceed, and then we will get going. So yesterday we talked about what can you find if you only have the radius of the base circle in that cone and the slant height of the cone. And we discovered that we could find pretty much anything and everything that we actually need. And so we're going to use that information to start today. And so notice I have given you here the base radius in this column, the slant height in this column. And so the first thing I'm asking you to find is the area of the base. That should be pretty basic. Remember our area formula is pi r squared, or r squared times pi. So that should be pretty simple. You're going to do that here in just a moment. Slant height is already given to you, and so this next section, remember, is just asking you for the ratio. And it's saying specifically to not simplify. So just write the ratio, do not put it in decimal form. All right, go ahead and fill out these sections, so these four, and then while you pause, and then when you're ready, go ahead and proceed so we can talk about that next section. All right, so before we move on, you should have these things filled out. Check your math to make sure you plugged everything in correctly. And again, the ratios here in this section should be left just like this, not simplified. So just hold tight to those as they are for the moment. If you need to fix anything or recalculate something and fix this, please do so now so that we can use this information as we move forward. All right, so next what we're going to do is find the lateral area. Now, if you remember, that is also, we saw from yesterday, that is the same thing, right, as that sector area of the bigger circle, which we don't really have today, but we're trying just to relate it back to what you've visually seen already. Lateral area is that piece or that sector from a bigger circle. This is the part of the cone that you're holding if you were eating an ice cream cone, for example. And so if you look back at yesterday's worksheet or even just our notes, in order to find sector area or that lateral area, we have our ratio of the angle over 360 times your pi r squared. Okay, now remember something to note, that this r, the radius, was of the big circle. So in our cone, that's actually represented by our slant height. Okay, so that's an important thing to note. Now, you hopefully are thinking, Ms. Puryear, there is no angle. We don't have anything about angles given to us this much. So that's why it's important to go back to yesterday. What did we discover about this yesterday? We said that if you're only given the base radius and the slant height, we can find that ratio. Remember, because that ratio is the same. That was one of our summary questions at the bottom of yesterday's notes. So that means this section here can be replaced by your ratio here. It's going to be the same thing. So all that to say, we're going to use this whole formula, but replace the things that we know that they are also equal to. And we're going to write those in here. So this is what this is going to look like. I'm going to do the first one for you. You're going to figure out the rest. So I want that ratio of angle to 360, which is actually the same thing now as the 2.5 over 10. So 2.5 over 10, that's going to represent the part, times the area, which is going to be found by pi, the radius of our original circle, which we don't know about, but that can be found with our slant height. So that's going to be 10 squared. Go ahead and find what that is equivalent to. And then I want you to go ahead and fill in the rest, find the rest of them. And you should have all your answers by the time you replay the video. So pause now and work on that. All right, so hopefully you've gotten to this point. And here, guys, is the most important thing that I want you to have is the formula. You should have this part written out every single time. So I should be able to see that ratio here times pi r squared. And by r, I actually mean slant height, yes? So I have the ratio times the slant height squared. Ratio times pi times the slant height squared. Ratio times pi times slant height squared. Hopefully you're remembering how all of these things are actually equal to each other that we've seen so far. Okay, check your answers just to make sure you put those into your calculator correctly. Now, notice these might have been kind of, maybe not difficult, but long. There's a long process here. You have to put this in, and some of you have to divide that, hit equals, then you times pi, then you square that. So there's a lot to kind of keep track of. So as we move down, it says now, look at the work we did to find the lateral areas, which is what we just did up here, okay? How could we find the lateral area without showing as much work? So what we're going to do is simplify the work that we showed above. I'm going to write something, so go ahead and follow along. We're going to look at that first example up top, 2.5 over 10 times pi 10 squared. All right, so we're going to start with that initial 2.5 over. Notice I'm making a really long over, because when I'm multiplying pi times 10 squared, all of that can be written as fractions over 1. And so it really means that I actually just have a really long numerator. So I have pi, and I have times, and then what I'm going to do is 10 squared is actually going to be written, for the sake of what I want us to see, as 10 times 10, which is what something squared means. So now I want you to take a look at this and go ahead and pause the video when I'm done explaining. I want you to see, is there any way that I can simplify this without actually doing any math, right? How can I make this look a lot simpler? And I don't want you just to go back to what we had up here. Is there something mathematically that can happen here to simplify that expression? Pause and think about that. Maybe talk to your neighbors about that. See what you can come up with. All right, so I'm not sure, obviously, what you guys came up with, but here's hopefully, or at least what I was hoping that you would see. Now, if you remember from a long, long time ago, different things that you've seen, when you have a fraction, okay, you can simplify things. So for example, if you were to break this whole thing up, what we would really mathematically be allowed to do is notice that this 10 here in the denominator, there's also a 10 in the numerator that's being multiplied. And so when you have the same thing on top and bottom, what we can do is actually cancel them out. So if I were to cancel one of the 10s on top with the 1 10 on bottom, I would actually then be left with 2.5 pi 10. Now, what I want us to think about is, where are those numbers coming from? Can we find these numbers somewhere else so that I could skip this whole process and go straight to here? And what I'm hoping that you're seeing is that, hey, yeah, I've seen a 2.5 before. That was the radius of the base. Oh, yeah, I saw that 10 before. That was the slant height. And so this should be coming and forming, right? So I'm going to give you just a moment to skip down to this next question. Based on this, how can we find the lateral area if we only know the radius and slant height? I want you to actually write down a formula for finding the lateral area. And so it should something like lateral area equals, and then I want a formula, meaning only letters or symbols, no actual numbers other than pi, but you're using this symbol for pi. Pause and write a formula for me. All right, so now I know that yours might look a little different than me because I am using some variables here that you may not have defined. But the idea that you should have is that you should have pi, which is coming from up here, times the radius of the base, which I just defined as r here, and times the slant height, which I put as an L, a cursive L. So what I want you to do, hopefully you got that right, pat yourselves on the back, give your neighbor a high five, something to encourage one another that, yes, I actually got that. If you didn't, that's okay. Now you do. So write this down so that we know what each letter represents. And then go ahead and write this part of the formula. This is the lateral area. Remember, that's the actual part of the cone that you would hold in your hand. Now, that next question says, okay, write the formula for the surface area of a cone. Now, we've just talked about the lateral area. Again, lateral area is just the part that you hold, like the actual waffle cone of an ice cream cone. But what we are also needing to include, so we're going to include the base circle. Our cones didn't really have that space, but most cones have like a solid base. That circle is filled in. So we want to make sure we include or add that base circle. So go ahead and pause and think about, how would I write the entire surface area? So how do I find the area of the cone and that circle base? And write me a formula. Pause and talk. Try. All right, so here's what I'm hoping that you could come up with. So the surface area for a cone is comprised of the area of the base circle. Area for a circle is just pi r squared. That's going to represent the bottom of your cone. And then we also have to add the lateral area, which we just discovered in the previous question, which is pi times the radius times the slant height. That is now your formula for finding the surface area of a full cone with a solid base. That's what we're going to be using in these next couple of practice problems that we go into. And so when we come, I'm just going to do the first one with you. Every one of them is going to be set up with that formula. So I'm going to start with surface area is equal to, and we're going to do pi. Again, the r, the radius of the circle on the bottom. So if you notice here, we don't actually have the radius. They give us the diameter. So our radius is actually going to be 4. So we're going to go pi times 4 squared plus pi times the radius times the slant height. Go ahead and pause the video, figure out the answer to this one, and go ahead and move on to that second question. And so when you come back, you'll be checking both of those answers. All right, so check your answers. Here, that first one should be 197.29 meters squared. We're still finding area, so our units need to be squared. And the second one you should find is 268.61 inches squared. That pretty much sums up everything we're going to be doing. So you're going to be doing the rest of the back of this notes as practice. until you can, I will tell you that the next one, number 3 is what we're going to call it. Whoops, 3. There is, so notice the 12 yards is not the slant height. Okay, so here's the only hint I'm going to give you on this particular problem. We know those, but we actually want to know this. How do you find the green length as your slant height? You're going to have to figure that out first and then apply that surface area formula. The rest is on you. Check with one another and the substitute to check your answers so that you can get your notes completed successfully in order to earn your homework. Sorry I missed you guys today. I hope you have a great weekend and we will see you Monday. I'm out.